Hello, everyone. This is our last lesson for the semester. I'll have a review posted sooner than later, hopefully by Wednesday, maybe tomorrow, not sure. Let's just get it done. So this lesson is going to be a lot like the previous ones in that we're using all of the same stuff. We're just going to go ahead and be solving the problems. And I need to make sure you can see my document camera. Yeah, that looks good. All right. So this one we're going to use this formula. So ax, y is 2, a is 4, x is x. So we have x equals 4 squared. So the solution set is 16. This first one right here, I kept typing in the answer when I first did it. They just want you to write this using logarithms though the first time, and then here we're going to write the answer. So let's go ahead and do x, y, our a is 3, our x is 11x, and our y is 3. So 11x equals 3 cubed, 11x equals 27. And that's what we put right here. And then when we go to solve, we divide by 11. So x equals 27 over 11. Solve the following logarithmic equations. Same thing here. So we have ax, y. Our a is our base, which is 4x is 5x, y is 3. So 5x equals a y. So 4 cubed is 64. So 5x equals 64. And they want the solution set. So we go ahead and divide by our 5 to get x equals 64 divided by 5 because that does not simplify or reduce. Same thing here. So a x, y. Our a is our base, which is 4. Our x is 2x subtract 5. And y is 2. So we have 2x subtract 5 equals 4 squared. So 2x subtract 5 equals 16. Solve for x. 2x equals 21. Divide by 2. X equals 21 over 2. That doesn't reduce. That's the first 4. And there's only 11 questions on this assignment. Okay, on this one, the rule we are using is, did I not write this one down? I guess not. Let me get it real quick then. So since we have log with the same base on both of these, it's going to be this one right here. So m equals n. Since we have the log with the same bases on this one, so we're going to have x plus 9 equals 13. And we solve for our x. So subtract 9. X equals 4. And on this one we have 25, and if we get the same base for both of these, we can use not on this paper. I don't see it. Well, it's exponential, so. we can use this one right here. So if we have the same bases on this, we can just compare our exponents. So we know 25 is 5 squared. So we'd have 5x minus 1 equals 5 squared. So then we can take that and have x subtract 1 equals 2. Add our 1. So x equals 3. Here we're going to use this because I can't make 6 be 3 with an exponent because 3 squared is 9. So we have a x, y. Our x is 6, a is 3, and y is x. So y is x equals log with a base of 3, and x is 6. So we solved that equation for x, though, when we changed it to logarithm. So log base 3, 6. Same thing here. So a, x, y. Our a is 7, our x is 3.3, and our y is negative x. So we'd have negative x equals log base 7, x is 3.3. X cannot be negative, so we divide by a negative, which makes this side negative, so we have x equals the negative log base 7, 3.3. So negative base 7, 3.3. Four more left. Solve the exponential equation, express irrational solutions in exact form. So the first thing on this one I'm going to do to make it look like this so that I can use this would be to divide by 2 on both sides. And I'm going to go ahead and grab another piece of paper. So we have 9. So I want it to be able to go into this form. So I'm going to divide by 2. So out of 8, 4x equals 9 halves. Now then with this, I can have my x and y. My a is 8, my x is 9 halves, and my y would be 4x. Yeah. Then rewriting it, I'd have y is 4x equals the logarithm of my base, which is 8, to 9 halves. Now I'm solving for x, so we're just going to divide by 4. So x equals 8, 9 halves all over 4. I'm going to go ahead and write that over here. So log 8, 9 halves all over 4. All right, 10. We have 4. 1 subtract 9x equals 5. So since I cannot make these bases be the same, so my exponents, I can just compare them. We're going to, how do I explain this way? We're going to turn them into natural logs, and then we're going to use the rule with the exponents. This one. where we take our exponent and put it in the front. So we have 1 subtract 9x times the natural log of 4 equals x natural log of 5. We're going to distribute here. So we'd have the natural log of 4 subtract 9x natural log of 4 equals x natural log of 5. Then we're going to get all of our x's on the same side. So we're going to add this. So over here that's 0. So we have the natural log of 4 equals x natural log of 5 plus 9x natural log of 4. Now then, since we have an x with both of these terms, we're going to factor that x out. X natural log of 5 plus 9 natural log of 4. I'm just rewriting it first. Then continue to solve, so we divide here. To get our final answer that x equals the natural log of 4 divided by the natural log of 5 plus 9 times the natural log of 4. And that would be the final answer right there. So x equals divided by the natural log of 9 plus 9 natural log of 4. Right. So we have 3/8 x equals 5. So same thing like we did on the last one, we're going to have the natural log of 3/8 x equals the natural log of 5, 1 subtract x. We're going to take these, and using this rule, we're going to put them at the front. So we're going to have x so distribute here. This side stays the same. Then we're going to get our x's on the same side, so I'm going to add this one. I can't combine them because they're not the same natural log. Factor an x out. Divide. So x equals natural log of 5 divided by the natural log of 3/8 plus the natural log of 5. And that is all for this chapter and this semester. And I hope you took something away from all of this. I'll have these uploaded for you.